Hello everyone, welcome to class 6 in our Cybersecurity Foundation series. So today we are going to talk about network monitoring with Wireshark. The learning objective of this course is that at the end of this course, students should understand what packet analysis is and its role in cybersecurity and network troubleshooting. Install and use Wireshark to capture and analyze network traffic. Use display filter to isolate and investigate specific protocol. Analyze the structure and content of captured packet, header, payload, protocols. Capture and intercept ICMP, that is a ping, and HTTP web traffic. So what is packet analysis and why it matters? A packet is the basic unit of data transmitted over a network. Every time you load a website, send an email, or stream a video, data is broken into packets. So, since we have knowledge of packets, then what is packet analysis? Okay, I think this is it. So the process of capturing, inspecting, and interpreting these packets is packet analysis. It is also called traffic analysis, packet sniffing, or deep packet inspection. Why it matters in cybersecurity? Troubleshooting, slow or broken connection. Packet analysis helps you know if a server or if an endpoint is being reached because it takes note of the packet that is being sent and the response that is being given from the server and see if there is a broken connection between them. This helps in troubleshooting network issues. Detect malicious activities such as data leak, malware communication, or port scanning. So things that has to do with malicious activity, like maybe there are huge traffic to a site. There's a kind of malware communication. Maybe a server is redirecting its communication to a bad URL. Maybe there is a port scan, severe port scan on the server. Wireshark helps to detect all this. Audit compliance with organizational policies. All the organizations have their policies. Packet analysis helps to detect these packets and ensure that they work with the organization policies. So, understand exploits by inspecting payload or flag in headers. Understand exploits by inspecting payloads or flags in headers. Installing and launching Wireshark. What is Wireshark? Wireshark is the world-based, widely used network protocol analyzer. It captures real-time traffic and allows deep inspection of hundreds of protocols. So Wireshark is used in industrial settings or in real life to capture packets based on the interface that is being specified. And then these packets can be saved as a pickup file for further analysis, or it can be analyzed in real time as the packet is being captured on that interface. So how do we install it on Linux? It's just a normal way of you installing your software. You just have to update your repository using the sudo apt update and then sudo apt install Wireshark. So during installation, accept to allow non-root user to capture packet. Then run sudo usermod with this option ag Wireshark with the amp with $, then the name of the user. Reboot or relogin for group change to take effect. Capturing live traffic in Wireshark. First, you need to launch your Wireshark. Select a network interface, which can be ETH0 or WLAN 0 or EMP0S or so to begin capturing. Click the shark fin icon to start live capture. Perform some network activity. Visit a website, ping a server, refresh an app, and then take note of the activity that Wireshark captures. Check the red square icon to stop the capturing. Using filter in Wireshark. What are display filter? Filter allow you to focus on a specific protocol or conversation. Common filter. Okay, let's do this. Common filter. We have the HTTP, which show only HTTP packets. We have the ICMP, show only ping ICMP packets. We have the tcp.port equals 80, which filter TCP traffic on port 80. We have the IP address equals to 192 or 168, depending on the IP address you want to look into, which show packets to and from that specific IP. DNS, which show DNS traffic. TCP contains login. Search for login in TCP payload. So lab work. We are going to capture a live traffic while we ping Google site, and so that we can inspect the DNS packet and the ICMP packet. Then we are going to also use a predefined packet, a pcap file that was analyzed by our senior colleague, Hackersploit, is available on his site. And we are going to use that packet as well and show some analysis on how he discovered a payload that was attacked, that was used to attack a server. So let's get to our Kali Linux lab. Meet you there. Welcome to our practical demo on class 6 in our Cybersecurity Foundation training. So we are going to take a look at Wireshark and then try to do some ping requests, capture it with Wireshark, and try to analyze a pcap file that was posted by one of our senior colleagues, Hackersploit. So stay tuned and you will enjoy this session. So first, we need to start our Wireshark, sudo Wireshark, then ask for password, put in a password. So when you're starting Wireshark, you need to choose your interface that you want to monitor, and then you can see these are the list of my interface. Excuse me. Okay, so this is the interface I want to monitor, ETH0 interface, because that is the interface that is connected to my WAN network. So I'm just going to double click on it. You can also filter a packet while you are capturing those packets live, but I advise you capture all the packets, then you can do the filtering later. So I'm just going to double click on this, and it has started capturing the packets. So let's do some ping requests from here. Okay. Pair this up with ping Google. Okay, so we're sending a ping request to Google. I think that will be okay. So you can take a look at ICMP packet, which is the ping packet that is then sent, and then DNS and UDP and other packets. So we are going to stop our ping request now. So as we have stopped our ping request, we stop capturing. They can filter by packet ICMP. So this is all our ping packets where we this is the time. This is the source IP, which is our own IP address 10.252.69.19. Then destination IP 142.250.183. Sending ICMP packets, and then this is the length of the packet. So if you want metadata or details and data about the ping request, you can see it from here. can see it from here. This is destination IP, IPv4 protocol, which give you the source IP and then destination IP as well. And then you take a look at this source address. This is the source address, destination address. So that is zip for filtering. Can filter ICMP. So this is an echo ping request. Echo ping request. This is what the reply from the server. This is a request. This is a reply. This is a request. This is a reply. This is a request. This is the reply. So you can see that we are just doing a ping request and a reply. Then another thing you can look into is the DNS packet as well. So this is the DNS kind of packet from this source IP 10.252.69.6. The source port for DNS server is 53. So we are sending a packet on this port 53 to this destination 10.252.69.55. This is our gateway. On this port, this is our port that we used. 53607. It is a DNS protocol. Okay, so it is a DNS response. This is a DNS response. I mean to say because look at it is replying to this IP 10.252.696 on this port 553, which is the DNS port, and this is the destination IP. This is the destination port. That means when the source system was making the request, it was using this port, and then the query is in 93. So you can see it's a query response, query responses. So you can look at the metadata, the frame, the Ethernet, and then the IP. Okay, so the frame is the data that goes into the wire. So you can see the encapsulation type is Ethernet 1, the arrival time, and the rest, the protocol, captured length, which is 91 bytes. The same thing as here, so 91 bytes. The frame is marked false. Frame is ignored false. Protocol in frame, Ethernet type, IP, and then UDP, and the rest. So that is it for that. I'm just going to do this. So IPv4 in the internet protocol level. In the internet protocol level, you can see we have here version 4. This is the source IP. This is the destination IP. This is the protocol UDP. Header checksum, source address, and the rest. So you can see that using protocol UDP, and then the source port is 53, destination port is this, the length of the data 57, checksum. So this length of the data, which is 57, when once it is added with all these other checksum or headers, the Ethernet header and other like the IP header as well, that's make the data to be up to a length of 91. So you can actually take a look at the data in details, what was actually done. You can see that this was a query, and then it was querying for IPv4 address of google.com. Was querying for the IPv4 address of google.com, that is 216.58.215.174. So this is a DNS response, replying it with this IP address, like telling the requester that, okay, look, this is the IP address for this. So it's a query answer from the DNS server. So having looked at that, we are going to also do some packet analysis as well in one of our PCAP file. I told you that one of our senior colleague, Akasploit, and do some analysis with the PCAP file. So this PCAP file is available if you want it. You just have to comment on this video, and then the PCAP file will be delivered to you as you need, maybe for your practical use. So I think we are going to just go over to our download folder. So let's do that. Okay. Download folder. let me get rid of this. Then we go here, then download. Okay, so this is the picker file, this is the keylocks file, and that is the session keys and the rest. So you don't need administrative privilege to analyze a picker file. So we just have to double click on it, and then we are opening. This is the picker file. So you can see that this was a Windows endpoint network, let me put it that way. So most of the hosts on this network are a Windows machine, because NB NS protocol, basically Windows machine really make use of it. You can see ARP protocol, which is broadcasting, trying to find the IP address of a system. So you can see who has this IP address, tell this person who has this IP address. So we are not basically going to look at what really happens in all the network traffic, but you can see some interesting things. We have the TCP packet, which is maybe it's trying to do a TCP connection. We have three handshake connection with TCP. So TCP is just trying to ensure that there is a end-to-end connection between the two systems. It's not the same thing as TLS connection, because TLS connection is trying to make sure that they have a secured connection. So you can just take a look at the TLS handshake. Okay, so TLS handshake. So we can look at this. See, this is a client hello, client hello, client hello. So TLS handshake is just trying to ensure that there is a secured connection between the server and the client. So whereby the client will request a TLS connection from the server, and then the server will look at the details and know the TLS version to use, knows the encryption type to use, and the rest. Then they will share a public and private key. So anytime the client is making a request to the server, it's going to make use of the public key, and anytime the server is trying to make a response to the client, it's going to use the private key. So that each of those data that is being transmitted along the internet will be only decrypted by the device that is ready to make use of that data. So even if somebody sniff into the network and try to look at what really happens between the two systems, they won't have access to the data. So same thing here, because most of the connection with TLS connection, we are going to just go in and then put in our keylocks session keys, so that we can have access to decrypt most of the TLS connection and see what really go between the two systems and see what really happens in the network that day. So you just come to your edits, then preferences, and then protocol. The protocol you are looking for is TCP. Okay, so you just have to go down a little bit down. TCP. Oh, TLS, please. The protocol we are looking for is TLS, not TCP. I mean to say TLS. So you can see this is our keylog file. I'm just going to browse it again so that maybe you see where the keylog file is. So this is our keylog file. Then we are loading it, we open it, we apply it, then okay. So now we can have access to decrypt most of the TLS connection or TLS data, because we now have the session keys being installed on this pickup packet analysis. So first thing we are going to do is we are going to look at the TLS handshake. Okay, so these are the various TLS handshake between the client and the server. You can see this is Skype software. This is foodgoodforliver.com. So all these are just TLS session between the client and then the server. So we are just going to look at something interesting, and that will be http.request or TLS connection, TLS.handshake dot type equals to 1 and not SSDP. So you don't want other distracting protocol to come in. We just want this. So you have filtered that. Okay, so you can take a look at this and you see that we have a client connection and client trying to establish a TLS connection and between the server and the client. Then this is a GET request. That means maybe it's trying to download something. We can follow up and then you look at the TCP string. For some reasons, I guess it's that decrypted. Let's try it again and follow this up. Wow, I think we lost that. Okay. http.request or tls.handshake. You can actually save this filter so to save yourself the stress of having to type everything again once you lost the filter. Okay. Equals 1. Equals 1. And not SSDP. SSDP. So we filter that again. So this is a GET request. Yeah. I think I was trying to download some office document or so. And then this is a post request. That means maybe it was server was trying to submit some things to this site. But you can look at very interesting thing that this server or any system, this system was trying to download something from the from a server. So it was trying to download invest 20.dll. This is a DLL file. So this actually captures our interest, because why should a system be downloading this from a server? What does it want to use it for? Okay, so we can look at the source port that tried to do that. And then this is the source 10.4.1.101 on this port, and then this is the destination, which is the server that is trying to download that particular file from, connecting at this port 443 and it's HTML. So we can follow stream and then we look at the TLS stream. So it was a GET request to this, and user agent was using Firefox to make that request and to this site, foodgoodsforliver.com. You can see that the download was successful, and the date, this is the date and time, this is the length, this is the last modified, and accept byte. So for the fact that this is a 200 code, it means that the download was actually successful. So you're going to investigate this further. So because of that, you choose this, and then you go to edit. We're trying to save it as an object. Okay, you go to our file, then we export objects. We export object, and then this time HTTP. Okay, so we're just going to look at what we want to export as object, which is this. Okay. Then I think we save that. Let's save it in our desktop. Okay, so once you do that, you go to our Firefox. You go to our Firefox, and then we try to do. We go to VirusTotal, which is a site for finding out what a particular object is, or a particular file is, if it's a virus or if it's a malware, or depending on what it is just going to try its best to review. So we are going to go to our desktop. Then this is what we saved as an object. We invest to underscore 20.dll. Then we open it. We just wait for some time. Okay, so Wireshark will try to give it a reply. You can see that according to the community score, 57%. That is a crowd dried DLL is the virus. So you just try to explain this as a malware. Win32, this mostly where it attacks. Okay, so Trojan. You can look at the detail here. Detail about the virus, the history, the name, where it attacks the signature. Again, you can see that the file is not signed. You can see the relation. You can see the behavior of the file. Okay. Let's try to go back here. You can also see the community replies. So this is a reply. File present on VX underground or the file exchange. And then this also reply. For a lot of security analysts, maybe this file was found in mail share and can be downloaded from this link. So for more information or to report interesting /incorrect findings. So is that actually the comment? I can also add your comment. So give your malware a free spin. So we can discover that this is a malware. Automatically, this is a malware. And do that with virus total. So this would take us to the end of our class on analyzing packets with Wireshark and then finding some interesting things on Wireshark pcap files. So we have seen how we can analyze packets. You can see how we can filter some packets, the ICMP packet, the DNS packets, and then we looked at the metadata as well. And then we can see how we can analyze the packet maybe that is being given to us in a pcap form, maybe by our other security analysts and to just look into it. Maybe the system was under attack. So that has taken us to the end of this course. And thank you for watching up to this moment. I hope to see you in our other series. Goodbye. One love.